Okay, my dear students, we are going to the chapter-wise concept. The topic is trigonometry. Now we are going to the trigonometric ratios. So that is trigonometric ratios of standard angles. The standard angles we have to take 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now we have to easily remember these angles of trigonometric functions like sine, cos, tan, cot, tan, secant, cosecant according to the tabular form. Okay. Now we have to write the tabular form for this one. Now we have to take the angles, standard angles 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now from 0 we have to take 0, 1, 2, 3, 4. Now divide by 4 all these numbers. By 4, here it is by 4, here it is by 4, here it is by 4, this is by 4. Now apply root for each number, square root. Apply square root for each number. Now from this, yes, 0 by 4 is 0, root 0 is 0 and root of, that means root 4 is 2, that's why 1 by 2 here it is. Now this is 2 times gets cancelled, that's why 1 by 2, root of 1 by 2 is nothing but 1 by root 2 and here it is 3 by 4, that means root 3 by 2, this is root 3 by 2, now this is 1. Now these are the results of sine function. That means sine ratios, sine theta, that means sine 0, 0, sine 30, 1 by 2, sine 45, 1 by root 2, sine 60, root 3 by 2, sine 90, 1. That means we have to easily remember these trigonometric ratios of standard angles. Now, after sine we are going to cos, for cos theta. If theta we have to take 0 degrees, 30 degrees, 45 degrees like that. So cos is reverse of sine. That means here it is 1 from that side. 1. Here it is root 3 by 2. Then it is 1 by root 2. And here it is 1 by 2. And it is 0. That means cos 0, 1. Cos 30, root 3 by 2. Cos 45, 1 by root 2. Cos 60, 1 by 2. And cos 90, 0. That's all. Now sine by cos. Sine by cos is tan. So tan theta is equal to sine by cos 0 by 1, 0. Right. And here 2 gets cancelled. Then 1 by root 3. Now this one by this one, 1. And here 2 gets cancelled, root 3. Now 1 by 0 is undefined. It is represents infinity, infinite. So undefined represents infinite. Now cot. So cot theta. You have to write from that order. So infinite, root 3 and 1 by root 3 and 0. That means tan 0, 0, tan 30, 1 by root 3, tan 45, 1, tan 60, root 3 and tan 90 undefined, infinity. So cot 0 undefined, cot 30 root 3, cot 45 1 and cot 60 1 by root 3 and cot 90 0. Now secant. Secant is the reciprocal of cos. Secant is the reciprocal of cos, that is 1 by 1, 1 and 2 by root 3. This is reciprocal of this one, 2 by root 3. Then reciprocal of this one, this is root 2. Then reciprocal of this one, this is 2. Then 1 by 0 undefined. That's why secant 90 undefined. Now cosecant. Cosecant of the ratios. Reverse. So infinite, undefined and 2 and root 2 and 2 by root 3 and it is 1. That's all. So these are the standard results for trigonometric ratios of standard angles. So this make a tabular form. This make a tabular form like this. So you can create a tabular form for this. So these are the angles and these are the angles. So here these are the functions. Now here you have to take tabular form like this. Now from this, observe here sine 0 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 91. That's all. So these are the values of sine function. These are the values of sine function, and these are the values of cosine function, and these are the values of tangent function. That means tangent ratios. These are the values of cotangent ratios. Now these are the values of secant ratios. These are the values of secant ratios, and these are the values of cosecant ratios. That's all. Cosecant ratios. Now from this tabular form, what you observe at 45 degrees, that means at 45 degrees, sine and cos equal. Sine and cos equal. At 45 degrees, tan and cot equal. And secant and cosecant equal. At 45 degrees, sine and cos equal, tan and cot equal, and secant and cosecant equal. That's why this is the most important tabular form, since with the help of these standard angles, trigonometric ratio, we can do the questions. This is useful for not only trigonometry, in remaining subjects also we have to use these tabular form. From that means trigonometric ratios of standard angles. Okay, write it fast. Now we are going to trigonometric ratios of an angle minus theta. That means sine minus theta, cos minus theta, tan minus theta, like that. So we have to prove that. Of course, this is in different quadrants, so first quadrant, second quadrant, third quadrant, fourth quadrant, like that. So we have to take one of the quadrants. So take the diagram, that is. Now we have to take a revolving line. Revolving line makes an angle theta in the anti-clockwise direction. That's why it is positive. So it is taken as P, x comma y be the point. Now this is y, length of y coordinate, that means y axis, it is y. Now this is x. This is always positive hypotenuse, so small r taken as. So according to the trigonometric ratios, what are the trigonometric ratios from this diagram? From this diagram, sine theta is equal to opposite side by hypotenuse. Since this is opposite side, this is hypotenuse, this is adjacent side. Now that is y by r, and cos theta is equal to, what is that? Adjacent side by hypotenuse. It is x by r, and tan theta is equal to opposite side by adjacent side, y by x. Now cot theta is equal to reciprocal of this one, that is x by y. Now secant theta is equal to reciprocal of cos, that is r by x. Now cosecant theta is equal to reciprocal of sine, that is r by y. So these are the standard trigonometric ratios when the revolving line OP in moving in the anti-clockwise direction in first quadrant. Now its reflection ray OP dash, its reflection ray OP dash. So moving in the clockwise direction, then it is minus theta. moving in the clockwise direction, then it is minus theta. Then its reflection ray moving in the clockwise direction, so it is makes minus theta. Now its length is, it is y, it is y dash. Now it is x. Now this is t dash, that is x comma minus y actually, since this is minus y. Right, now we have to write, from this we have to write sine of minus theta is equal to, from this right angle triangle, since here it is right angle, here it is right angle. From this right angle triangle, suppose you have to take, it is A, OA P dash, sine minus theta is equal to opposite side, that is minus of, it is taken as y dash, that is better, y dash by x, sorry, y dash by, it is r, same length, that is y dash by r. Now from this one, this is minus of y dash, this length is equal to this length, that's why it is y by r. Actually y by r is nothing but sine theta, that's why sine of minus theta is equal to this y by r is sine theta minus sine theta. That's all. Cos of minus theta, that is, actually this is taken as, so this is x, OA is x, and this part OA dash taken as x dash, no problem, x dash. That's why it is x, it is positive, no problem, it is x is same, OA is x, that's why it is x by r. So what is x by r? X by r is cos theta. That's why cos of minus theta is cos theta. That's all. Now tan minus theta. Tan minus theta, that is opposite side by adjacent side. That is minus of y dash by x. Y dash by x. Now this is minus of, so y dash is nothing but y, since these two equal, y by x. Actually y by x is tan theta, that's why this is minus tan theta. So tan minus theta is nothing but minus tan theta, and secant cot minus theta, that is adjacent side x by minus y dash. Same here also, minus of, it is x by y dash is nothing but y, since they have same lengths. So y by x by y is cot theta, that's why it is minus cot theta. And now secant of minus theta, that is the reciprocal of this one, that's why secant of minus theta reciprocal of r by x, that is already r by x is nothing but secant theta. So secant minus theta is plus secant theta, and cosecant minus theta is equal to, so reciprocal of sine, that is, since that is minus of r by y, so this is minus cosecant theta. That's all. That's why sine minus theta is minus sine theta, and secant, so cos minus theta is plus cos theta, tan minus theta minus tan theta, cot minus theta minus cot theta, secant minus theta plus secant theta, and cosecant minus theta is minus cosecant theta. Are you clear? Except secant and cos, so remaining rest of the functions of negative angle gives same negative functions according to this proof. Okay, so proof is not necessary, that's why you can remember the formula sine minus theta minus sine theta, except cos and secant, remaining sine minus theta minus sine theta. That's why tan minus theta minus tan theta, cot minus theta minus cot theta, cosecant minus theta minus cosecant theta. That's why these are the that means revolving line moving in the clockwise direction. For clockwise direction, that is negative angle. For anti-clockwise direction, it is positive angle. That's all. Now, basic relationships of trigonometric ratios, that means a quotient and reciprocals, like that. That means we have to write sine theta is equal to 1 by cosecant theta. Sine theta is equal to 1 by cosecant theta. These two are reciprocal to each other. Now from this we have to multiply this. So sine theta into cosecant theta is equal to 1. Sine theta into cosecant theta is equal to 1. Again from this we have to write. Cosecant theta is equal to 1 by sine theta. That's all. So sine theta is 1 by cosecant theta and cosecant theta is 1 by sine theta. Product of these two is 1. So these two reciprocal to each other. That means sine theta and cosecant theta gives 1. Product of them is 1. Similarly, cos theta is equal to 1 by secant theta. Cos theta is equal to 1 by secant theta. It gives secant theta into cos theta is equal to 1. So product of these two functions is 1. This can be right. Secant theta is equal to 1 by cos theta. That's why these two reciprocal to each other. And next, tan theta is equal to 1 by cot theta. Now from this one, tan theta into cot theta is equal to 1. Again from this one we can write cot theta is equal to 1 by tan theta, since these two reciprocals to each other. And also tan theta is equal to sin theta by cos theta. From this we have to multiply these two. Sin theta is equal to cos theta into tan theta. So this is the formula for sin theta. Sin theta is equal to cos theta into tan theta. Similarly, cot theta is equal to cos theta by sin theta. Now from this one, cos theta is equal to product of cot and the sine. That means it is sin theta into cot theta. That's all. You can revise all these forms. These are the basic concepts and basic relationships. That's why the questions depends upon these basic relationships. Now we are going to identities. Now identities of trigonometric ratios. So the first identity, that is sin square theta plus cos square theta is equal to 1. Okay, from this one we have to write sin square theta is equal to 1 minus cos square theta. From this one, sin theta is equal to square root of 1 minus cos square theta. Again from this one, cos square theta is equal to 1 minus sin square theta. From this one, cos theta is equal to square root of 1 minus sin square theta. Right. Now we are going to the second identity, that is secant square theta minus tan square theta is equal to 1. From this one, secant square theta is equal to 1 plus tan square theta. Now from this one, secant theta is equal to root of 1 plus tan square theta. And from this one, cosecant square, that means tan square theta is equal to secant square theta minus 1. From this one, tan theta is equal to square root of secant square theta minus 1. Now we have to create the forms from these identities. Next identity, that is cosecant square theta minus cot square theta is equal to 1. From this one, cosecant square theta is equal to 1 plus cot square theta. Now from this one, cosecant theta is equal to square root of 1 plus cot square theta. Right. Again from this one, cot square theta is equal to cosecant square theta minus 1. From this one, cot theta is equal to root of cosecant square theta minus 1. That's all. So these are the identities. Now we have to find from these. So secant square theta minus tan square theta is equal to 1. From this can be written secant theta plus tan theta into secant theta minus tan theta is equal to 1. From this, secant theta plus tan theta is equal to 1 by secant theta minus tan theta, since these two reciprocal to each other. From this, secant theta minus tan theta is equal to 1 by secant theta plus tan theta, since they are reciprocal to each other. Similarly here, cosecant square theta minus cot square theta is equal to 1. From this, cosecant theta plus cot theta into cosecant theta minus cot theta is equal to 1. From this, cosecant theta plus cot theta is equal to 1 by cosecant theta minus cot theta. From this, cosecant theta minus cot theta is equal to 1 by cosecant theta plus cot theta. That's all. So these are the reciprocal to each other. Okay, write it fast. Now from this, secant theta, if secant theta plus tan theta is equal to x, then secant theta minus tan theta is equal to 1 by x. If cosecant theta plus cot theta is equal to x, then cosecant theta minus cot theta is equal to 1 by x. That means these are reciprocal to each other. If it is x, then it is 1 by x. If it is x, then it is 1 by x. If it is x, then it is 1 by x. If it is x, then it is 1 by x. That's why they are reciprocal. Okay, bye. Right.